back to Cornell and went to graduate school in engineering physics. And I got my degree and my master's and then my PhD at Cornell using this phenomenon where an electron hits any kind of electrons, which is used in the photomultiplier tubes that open doors. When we walk up to a certain door and it automatically opens, there's a light beam that detects our presence, and as are released, and the secondary electron multiplies it and it sends a signal to open the door. And that's what we were doing. So I was interested in the application of physics in practical things, like one was to improve the ability to take X-ray pictures or fluoroscopy with less radiation, because we were using a lot of radiation during fluoroscopy. And a fluorescent screen, you stand there and they look at you for a few minutes maybe, and you get an enormous dose. And so it so happens that I was able to work on a big image intensifier that cut the dose in fluoroscopy by 100 to 200-fold. And that was done at the Westinghouse Research Lab because they heard me give a talk on my work at Cornell, and they asked me to come to work on the research of electron physics for imaging tubes. It's interesting because that was a very satisfying kind of work. It allowed me to think that I could help to reduce many unnecessary X-rays which produce a risk of cancer. And so early in life, I had been encouraged to do that by someone who I never would have expected it from, but it was Albert Einstein, the famous professor, who received the Nobel Prize in 1905, well, for his work that he did in 1905 to, to develop the special theory of relativity. His study was also included the process where a light beam hits a metal plate and knocks out an electron. And so a professor I knew, a distant relative, who asked me, why don't you write a letter to Einstein about how your theory that you're trying to develop is related to his theory on the photoelectric effect, for which he won a Nobel Prize. And so I wrote him a letter, and he invited me to come to Princeton. And I had the wonderful opportunity to talk with him about my work, and and he was such a nice, gentle old man. At the time he was already almost 70, and I was only 23. But he asked me whether I could still speak German, since I was born in Germany and was interested in physics. He said, let's talk in German, it's easier for me. And so we sat down and talked, and would you believe, I couldn't believe it. Sometimes the secretary would come in and he said, Dr. Einstein, there's someone waiting for you. Or he said, could you, would you like, me to tell you this? The other things you need to do. And he said, no, be right back. And he came back and we talked for 5 hours. And that, in effect, had an enormous effect on my life. Because, among things, he encouraged me to pursue my theory. And I finally got it all published. And then he also told me, let's go for a walk. I want to talk to you some more about your ideas on the nature of the fundamental particles of the universe, which were just being discovered. New particles were being discovered in cosmic rays, and it was a very interesting time. But there were some new particles that were much heavier than the electron, but less heavy than the proton, and they were disintegrating in an instant, but nobody knew what they were composed of. And I had the idea that since they all decayed into electrons, and I was always interested in electrons anyhow, I thought maybe the whole universe, this is the only truly fundamental particle, the electron and its opposite partner, the positron, that had the same mass but the opposite charge. And he said, keep on thinking about these things. And so he encouraged me to pursue this, but he said, look, don't go back into academia. They will kill every bit of originality out of you. In order to become a full professor, you have to get approved on every level, and you cannot question the existing ideas too much, or else you won't get promoted. So Einstein said, have a shoemaker's job for the rest of your life, so that you can do something useful for humanity, and don't make the mistake I made. I accepted a position in Berlin where I had nothing to do but to solve the mystery of the universe, and nobody can do that. And therefore, you should do that in the evenings and have a day job when you can work and do something really useful for humanity. And he was absolutely right. It allowed me to accept a position, in the research lab at the Westinghouse Research Laboratory in Churchill that had just been built when I was finished with graduate school, and they invited me to come. And I used my work that Einstein encouraged me to do to develop a new kind of camera tube. In fact, it's called the SEC Vidicon, and it was used by NASA to take the pictures that went along on the moon, to the moon, in 1969, and took the pictures of people stepping on the moon for the first time. And everybody in the world saw the pictures with what I felt was my camera tube, which is very nice because our group developed it at Westinghouse, and it gave me a great deal of satisfaction. And then later on, the same tube that was sensitive to the ultraviolet light coming from the distant universe was used in the first orbiting small observatory that was just like the Hubble but much smaller, and it gave us the first pictures in the ultraviolet light from distant stars, the most distant stars, 13, 20, 15 billion years away. 15 billion years it took to travel to reach our camera tube. And we had developed a telescope that would go on the moon, a small portable telescope, no bigger than a foot in diameter. It would have outperformed the biggest telescope on Earth because there's no atmosphere on the moon. And so I was looking forward to it, and then the Vietnam War cut it all off. Because the Vietnam War caused the NASA budget to be cut, and we stopped working, and we couldn't get another mission to the moon to set up the telescope that would have really given us a very early picture of what was going on in the beginning of the universe, how stars were formed and planets were formed, everything. And then later on came the Hubble. And the Hubble would have had my camera on it, but by that time, new solid-state television tubes were developed, the kind that we're using right now here in this room to talk about, to record what I'm saying. They're tiny little devices that make miniature cameras possible, and that meant that my SEC Vidicon was no longer needed. But it was a pioneer in terms of sending back pictures from the moon and from other stars. It's been used on other telescopes in the world, but not on the Hubble telescope.